Hello class, hope everyone's excited and ready to learn a little bit about flat field testing courtesy of Ruth and myself, Jesse. So according to Bouchon, flat field correction is software that creates a uniform response in the image receptor to a uniform X-ray beam. It is performed to equalize the response of each pixel to a uniform beam. This is a pre-image processing function that manipulates the image before it is displayed in order to reduce artifacts. Another pre-processing function is signal interpolation, which assigns a value to a dead pixel that is an average of the pixels surrounding it. Flat fielding is also known as gain calibration. We first noticed the anode healed effect in our image while Ruth was imaging bilateral hands on the same 16 by 16 detector at 40 inches. You can clearly see a dark to light gradient going from right to left on the background of the image. After showing the patient out, we looked at the X-ray tube to confirm that the cathode end was on the right. And flat field correction compensates for the anode healed effect, so you have a more uniform image. To run the flat field test at Northwest, we opened the QC application and simply followed along. We removed the grid as well as any objects in the X-ray's path. Then we aligned the tube with the IR and set the distance. Next, the flat field phantom was inserted into position on the collimator box. The phantom looks like a thick block of aluminum with tabs along the sides that slide into brackets on the front of the collimator box. Upon exiting the room, we made an exposure and then followed the instructions for a second exposure. To evaluate the uniformity of a flat field exposure, region of interest, ROI, samples are taken from each corner and the center of the image. The top number in each ROI is the average pixel value, and the bottom number is a standard deviation, or how much the pixels vary in that ROI. The average pixel value for the entire image here is 308, and the standard deviation is 33. According to Jeffrey Papp, author of Quality Management in the Imaging Sciences, the average pixel value must be between or be within plus or minus 10% of each other. To find the 10% difference between two numbers, we subtract the smaller value from the larger value, divide the difference by the larger number, and then multiply that by 100. So here we've compared the center ROI, or 319, to the upper ROI, 269, to get a difference of 15%. These pixel values were taken from a picture of an image, so they are distorted, but if they were accurate, then we would not be on compliance for uniformity. The acceptable limits for uniformity for one of Northwest digital X-ray rooms are listed in this image of test results. The upper specification limit for global brightness non-uniformity is 30. Global is the difference in average pixel values across the entire image, so there's more room for error because there's a larger sample. The local brightness non-uniformity upper limit is a smaller value of 5. That's because it's a smaller sample. And yeah, just look at that. We have no bad pixels, so no need for signal interpolation. These numbers are different than the plus or minus 10% recommendation by Papp. Perhaps this system uses the standard deviation values as a gauge for uniformity. Consequences of non-uniformity include poor image quality, artifacts, and dead pixels. These consequences can lead to misinterpreted X-ray images due to artificial changes in density across the image. A bad pixel could appear to be a small calcification that may lead to an incorrect diagnosis. So imagine if half of a patient's lung looked brighter than the other half. This could hide or create a pathology by masking variation in tissue density or creating a variation that isn't really there. After we did the flat field QC test, we did some test images and noticed that the non-uniformity is less obvious at a higher SID. This is due to the anode heal effect being less prevalent at longer SIDs because the beam is less divergent. So let's review with 5 short questions. First one, the non-uniformity caused by the anode heal effect is least prevalent at which SID? A40, B72, C48. Correct answer is 72 inches, B. Next, how many exposures are taken when flat field testing one detector? 2, 1, or 3? Correct, 2. All right, where is the flat field phantom placed? In the grid slot, in a drawer, on the table, or over the collimator box? D, over the collimator box. And according to PAP, what is the plus or minus acceptable limit for difference in ROI average pixel values? 37%, 10%, 15%, or 110%? B is correct. Lastly, signal interpolation is when a dead pixel is assigned a value that is the average value of its surrounding pixels. True or false? If you guessed true, you got it. All right, well, that's it for us. Thank you for your time. Best of luck with finals. We'll see you later.